and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is part one of the lesson on factor theorem, and in this first video I'm just going to explain what the factor theorem is and how it works. So what we have here is the original question, which is show that 2x plus 1 and x minus 3 are factors of 2x cubed minus 7x squared plus 2x plus 3. Now I did a little bit of an introduction as to what factors are when I did my video on algebraic division, and the principle of the factor theorem is that if x minus a, where a is a number, is a factor of f of x, which is a function of x, so some stuff with x's in it, then f of a will equal 0. So if we substitute the number a into the function, we should get the answer 0. Okay. So what that means is, for example, I'm going to do x minus 3 first. If x minus 3 is a factor, it means that f of 3 should equal 0. So what I'm going to do is I'm going to substitute the number 3 into this function here, and I should get an answer of 0. So 2 lots of 3 cubed minus 7 lots of 3 squared plus 2 lots of 3 plus 3. So that's 54, take 63, plus 6, plus 3, which is 0. And therefore, this is the bit students often forget to do, and therefore x minus 3 is a factor of f of x. And I can write f of x here. F of x is referring to this cubic here, this statement here. Okay. The other one I've been told is a factor is 2x plus 1. So if my factor is 2x plus 1, then I'm going to be doing f of negative a half. So this is just like if you had this as a bracket at the end of a quadratic equation and you were asked what x was, you would use x is minus a half. You're making this bracket equal 0 to find the number that you have to substitute in. So we know that f of negative a half should equal 0. So again, if we put minus a half into the same function, we're expecting to get an answer of 0. So 2 lots of negative a half cubed. Negative a half cubed is negative an eighth, so we've got negative 1/4. Minus 7 lots of negative a half squared. Negative a half squared is positive a quarter, so we're taking away 7 over 4. 2 times negative 1, take away 1, plus 3, and all of those sum to make 0. And therefore that means that 2x plus 1 is a factor of f of x, and remember that written conclusion is very, very important. What I've just worked out separately is that actually if you fully factorise this expression, then in addition to 2x plus 1 and x minus 3, the final factor is x minus 1. So these are the 3 factors of this function here. Each of these divides exactly into this with no remainder. We can show that using the factor theorem, that when you substitute the number in, you get the answer of 0. Job done.